Hi all. Today I am going to discuss about the basics of organic spectroscopy. Like all other science, chemistry plays an important role in our pattern of understanding the universe. It is the science of molecules, but organic chemistry is something more. It literally creates itself as it grows. Organic chemistry was started as the chemistry of life. At that time, it was thought to be different from the chemistry in laboratory. Then it becomes the chemistry of carbon compounds, especially that found in coal. But now it is both. It is the chemistry of carbon and carbon compounds that found in living things, the products of living things, and where else carbon is found. Now, how will you determine the structure of an organic compound? The answer is by using spectroscopy. And spectroscopy deals with the results of interaction of electromagnetic radiation with matter. Electromagnetic radiation consists of two components, electric field vector and the magnetic field vector, oscillating perpendicular to each other and also to the direction of propagation. The electric field vector is responsible for the interaction of electromagnetic waves with matter. That means atoms or molecules. Light can be considered as a stream of photons, each possessing a discrete quantum of energy, h nu. This energy is used for producing various types of energy transitions in atoms and molecules. Since different regions of the electromagnetic radiation process different energy, the responses produced in the molecules are different. For example, in the case of X-rays, photoionization is occurring by using this X-rays. And in the case of ultraviolet and visible radiation, electronic transitions are occurring in the molecule. And in the case of infrared radiation, it causes molecular vibration. And in the case of microwaves, it causes molecular rotation or torsion. Now, X-ray crystallography is the best ever known method to determine the structure of an organic compound. In the case of X-ray crystallography, the sample should be in the form of crystalline form, which diffract the X-rays, and we will get a diffraction pattern like this. And by solving this diffraction pattern, it is possible to deduce the precise spatial arrangement of atoms in the molecule, except that of hydrogen atoms, which are too light to diffract X-rays. So, the position of hydrogen atom must be inferred from the rest of the structure. So, X-ray crystallography is the perfect method to determine the structure of an organic compound. But in the case of X-ray crystallography, we need a perfect crystal. That means if the sample is liquid or a solid which cannot form good quality crystal, the structure cannot be determined by using X-ray crystallography. So in that cases, we will use the other spectroscopic techniques like infrared spectroscopy, ultraviolet visible spectroscopy, NMR spectroscopy and mass spectroscopy to determine the structure of the organic compound. Infrared spectroscopy. When energy in the form of infrared radiation is applied, then it causes the vibration between the atoms of the molecule. When the applied infrared frequency becomes equal to the natural frequency of vibration, then absorption of IR radiation takes place and a peak is observed. Different functional group absorb characteristic frequencies of IR radiation, hence gives the characteristic peak values. Therefore, IR spectrum of a chemical substance is a fingerprint of that molecule for its identification. These are different stretching and bending vibrations occurring in a molecule as a result of infrared radiation. And this chart gives the typical infrared absorption values for various types of bonds. For example, the OH stretching is, in the case of OH stretching, we will get a broad peak in the range 3200 to 3400 centimeter inverse. And in the case of carbonyl stretching, we will get a sharp peak in the range 1650 to 1800 centimeter inverse.